Lessons are going to be about two different types of vector products. Today we're going to talk about the dot product. The dot product, which is sometimes called the inner product, is a number that you get simply by product summing the vectors. And what I mean by that is to find the dot product between 3, 5 and negative 4, 3. What you'll do is you'll multiply the 3 and the negative 4 together because they're both in the same component. And we're going to multiply 5 and 3 together. When we do that, we get negative 12 plus 15, and that, of course, equals 3. And so we would say the dot product of those two vectors is 3. The dot product is always a number, as opposed to tomorrow's lesson, which is the cross product, which gives us a vector. If you have a three-dimensional vector, you do the same sort of thing. You simply multiply things component by component. So for 108 and 5, 3, negative 3, we would multiply the 1 and the 5 together. We'd multiply the 0 and the 3 together, and the 8 and the negative 3 together. That would give us 5 plus 0 plus negative 24, which gives us a negative 19. Now, one of the reasons why we find the dot product of two vectors is it gives us a way to tell if those two vectors are perpendicular. So, first question says, is the vector 4, negative 10, and 5, 2 perpendicular? Let me try to draw that a moment. 4, negative 2, we could interpret that as going 4 steps over in the x direction and 10 steps down in the y direction. And so it might look something like this. And 5, 2, we could interpret as going 5 steps over in the x direction and 2 steps up. And so I look at those two vectors, and they look like they're pretty close to 90 degrees to each other, maybe exactly. But it's hard to tell because I didn't do it very accurately. In order to test that, let's find the dot product. So we would multiply 4 times 5 together, and we'd multiply negative 2 and 10. Negative 10 and 2. When we multiply those, we get 20 plus negative 20. And that, of course, does add up to 0. And in general, if two vectors have a dot product of exactly 0, then that means they are exactly perpendicular to each other. So again, the dot product is exactly 0. That means the vectors are perpendicular to each other. Now, if you find that the dot product of two vectors is positive, well, that means the vectors are going in basically the same general direction. And if you find that the vectors are negative, the dot product is negative, then that means your vectors are going in basically the opposite direction. So, another application. What if we wanted to create two vectors that are perpendicular to each other? So we want to know what x coordinate we might need here in order to get x, negative 6, and 3, 8 to be perpendicular vectors. Well, why don't we start by finding that dot product? And so we would take x and 3 and multiply them, and negative 6 and 8 and multiply them. And if we want them to be perpendicular, we're going to set that product equal to 0. And this is a pretty simple algebra equation to solve. 3 times x is 3x, and 8 times negative 6 is negative 48. And so when we add 48 to both sides and divide by 3, we get that x would have to be 16. The dot product can do a little bit better than simply telling us whether things are close to perpendicular or kind of going in the same direction or kind of going in opposite directions. We can actually calculate the angle between two different vectors by using this equation here. The dot product is equivalent to the length of the first vector times the length of the second vector times the cosine of the angle between them. And so first question here is, what is the angle between these two vectors? And I've drawn them pretty good. This is 1 step over and 3 steps up. And then vector b here is 6 steps over and 0 steps up. And so I'd like to know what that angle is. So in order to do that, I would suggest first thing we do is write down this general equation. A dot b is equal to the length of a times the length of b times the cosine of the angle between them. And then we'll go about trying to find each of those things. So the dot product is, in this case, 1 times 6 and 3 times 0 added together. And so that would be 6. Now let's go about finding the length of A. Remember the length of A, we used the Pythagorean theorem. And so we'll take 1 squared and 3 squared and take its square root. So there's the length of A. 1 squared is 1, 3 squared is 9. So when we add those together, we get 10. And so the length of A is the square root of 10. And likewise, we can find the length of B. B is actually easier because it's only in one dimension, and so you don't have to bother with the whole distance formula. It's just a length of 6. And so if we put all those things together, the dot product is 6. The length of A is the square root of 10. The length of B is also 6. We have this equation. Oops. There we go. Switch programs for you. We're back. So 6, the length of A is square root of 10. Length of B is 6. And we still don't know what theta is, so that's there. If we rewrite that a little bit for cosine of theta, we get that cosine of theta is equal to 6 divided by the square root of 10 and 6 multiplied. And that's approximately 0.316. And then we have to get out our calculator, probably already did actually, and figure out what theta is. That would be the inverse cosine of 0.316, and that's approximately 71.6 degrees, which kind of looks like in the picture. The same process can be done in 3 dimensions. And so let's try a moment to find the angle between the vector 5i and 12k and the vector 4i plus 8j plus 8k. Let me first start by just kind of drawing that. So let's make a vector that is 5i plus 12k. That means 5 steps in the x direction, it should be down this way, and then no steps in the y direction because there was 0j, and then 12 steps in the z direction, just straight up. And so that might be something kind of like this. And then if we draw the second vector, b, that is 4 steps in the x direction, like this. It's 8 steps in the y direction, which should bring us over to here, and then 8 steps up, which should bring us, I don't know, somewhere around in here. And so there's an angle in between these 2 vectors. Unfortunately, I can't rotate this to see exactly what that is, but you know, it looks kind of small. 45 maybe? I don't know. We'll find out. So to actually calculate it, we have to have our dot product formula. The dot product of A and B is equal to the length of A times the length of B times the cosine of the angle between them. And so let's start by finding the dot product. Dot product is 5 times 4, and then 0 for the j component times 8, and 12 times 8. That would be 20 plus 0 plus 96 for a total of 116. Then we can find the length of vector A. The length of vector A is 5 squared plus 12 squared and take its square root. You might recognize that as a 5, 12, 13 triangle. 5 squared is 25, 12 squared is 144. That brings us to 169. If we add them up, the square root of that is exactly 13. When we find the length of B, the length of B, remember, is 4 squared plus 8 squared plus 8 squared and take its square root. And so that's 16 plus 64 plus 64. 16 plus 64 is 80, plus another 64 is 144. And that's conveniently a total of 12. That, by the way, is a Pythagorean quadruple. 4, 8, 8, 12. Just like 5, 12, 13 is a Pythagorean triple, although you didn't really need to know that. And so finally, we can put in all the numbers that we know into the dot product. We know the dot product itself was 116. Length of A was 13. Length of B was 12. When we multiply those together, that's 156. And so rearranging that for cosine of theta, we get that cosine of theta is the fraction 116 over 156. And if we type that into a calculator, we can find the inverse cosine to be about 42 degrees. So there's a couple examples of finding dot product and some of their applications.